Hi, so in this video, what we're going to do is we're going to try and differentiate the function cosech of x. So cosech just means, by definition, 1 over hyperbolic sine of x. So just like how cosec, by definition, is 1 over sine. So this is just 1 over sine of x. The same thing with these hyperbolic functions. So we just define cosech to be 1 over hyperbolic sine, or 1 over sinh or shine, however you like to call it. Okay, yeah, so yeah, we know those definitions then. And so in this video, what we're going to do is we're going to find this derivative of cosech. And it's very similar to what we did when we found the derivative in cosec in one of my previous videos. So we're going to use the quotient rule, and we're going to use this definition again to help us. So we know that this derivative is the same as just differentiating 1 over sinh of x. And again, we can just use the quotient rule to help us out here. So if we go to a new page, so we've got two functions divided by each other. So that's going to be the quotient rule. So when you use the quotient rule, you use this formula. So the derivative of the quotient of two functions is the derivative of f times by g, take away the derivative of g times by f, all divided by the g function squared. So if we just go back to the fraction we've got here, so our f function is going to be this number 1, and our g is going to be this hyperbolic sine. So let's just write that in like this. So f is 1, g is hyperbolic sine of x. Okay, so f dash hyperbolic, sorry, not hyperbolic. When we differentiate just number 1, well, that's just 0. So f dash is 0. So yeah, this is what I meant. So when we differentiate g with respect to x, hyperbolic sine, well, we know from previous videos that when you differentiate hyperbolic sine, you get hyperbolic cos. So this is just cos of x. And obviously g squared is hyperbolic sine squared. Okay, so now we can plug these results into the formula. So I'll just call this star. So therefore star equals, so f dash is 0. So this first term's actually going to be 0, because 0 times anything is just 0. And then take away g dash, which is cos. So we have cos x in there, multiplied by f, which is just the number 1. So that's our numerator. And our denominator is g squared. So hyperbolic sine squared of x. Okay, cool. So that means when we simplify it, we get negative cos x over sinh squared of x. Okay, so if we go to a new page and then try and rewrite this fraction that we've got here in a more simplified way. So we had negative cos of x over sine of x, or sinh, or hyperbolic sine. So if we rewrite it in a different way, so if we just rewrite it like this, so I'm going to split this the two hyperbolic sines. Sorry, there should be a squared there. So we're going to split the two hyperbolic sines multiplied together into two different fractions, like so. And then it should be a bit clearer how we can simplify these bits, or rewrite these bits, I should say. So we know by definition that hyperbolic tan of x from the previous videos is hyperbolic sine over hyperbolic cos. And so therefore we know that 1 over tangent, or 1 over hyperbolic tan, which is defined to be coth, or hyperbolic cot. So that's going to be cos over sinh. And so we know that this first bit over here is just going to be coth, or hyperbolic cot. And just put that on a box like that. So we're going to have negative coth of x multiplied by 1 over sinh of x, 1 over hyperbolic sine, which we know by definition is just the same as cosech of x. And so that's going to be our final result. And so in conclusion then, when we differentiate this cosech function, we get negative cof times cosech. So d by dx cosech hyperbolic cosec is negative cosech times by cof of x. And that's the final result.